In the slides, slides provided by the textbook has an example some slides on an empirical example of Hezbollah military event. I'm not familiar with this example, but there is nothing special in this example. It is just doing the same thing with what we did earlier. So I'm going to skip this example. Instead, I will spend more time on this. So, okay, I explained how the probit or the login model works, and the mechanism is explained. Then the next question is, how can we estimate them? So the linear regression model was estimated by the OLS method, ordinary least squares. It minimizes the squared residuals, the sum of squared residuals, but in this case, now we are predicting the probability. So residual also has no meaning. So like say you predicted 30%. You predicted the denial as 30%, but it was not denied. So then your observation is 0. Then is your estimate correct or not? You predicted 30%, and it did not happen. Then is your error 30%? So the residual cannot be interpreted in the same way as the linear regression with the continuous dependent variable. So we have to think about a different method to estimate that. And I will introduce the maximum likelihood estimation method. This is the how usually the how we usually estimate the probit or the login model in practice. And also theoretically, the maximum likelihood estimation is the best estimator, is the optimal estimator in theory, in statistics. So this is the most theoretically important estimation method in statistics. It has many optimality properties and can be applied to numerous models, and it's so important. So I will. By the way, the slides are not enough. I think I didn't like the slides at all. So I made up my own slides. So let me try. I will explain the maximum likelihood estimation in a very casual way without using much mathematics. Uh, Even if I say it is theoretically important, but I'm not going to show you the theory, but you just need to understand the mechanism, how it works, what we are estimating, how we are estimating. To do that, I will think about an interesting example. So this is the NFL divisional round in the last season. So you don't need to know what is what. You don't need to know what they mean. So what we are doing here is just imagine there are 4 matchups in a weekend. There are 4 matchups, and you are betting. You are playing a sports betting game. So I am going to explain. So imagine it is of course it's a hypothetical game, and I will explain you how you have to play this game. So there are 4 matchups: Rams and Packers, Ravens, Bills, Browns, Chiefs, and Bucks and Saints. There you have to choose. Usually, you have to choose who is going to win. However, now I will consider a slightly different way of playing. I am going to instead of naming the winner, you may instead of just simply naming one team, you have to assign probability of winning to each team. Say in the matchup between Rams and Packers, it is just an example. I'm neutral, so I think the Rams is going to win with 30%, and the Packers winning probability is 70%. Sorry, Rams fans. It is just an example. So this is your bet, and like Ravens Bills 50-50. And sorry, I'm very sorry for Browns fans, but I expect Chiefs to win with 90% and Bucks 40%, Saints 60%. So in this way, this is my betting. I bet like this way. Of course, in a matchup, the summation of the probabilities must be 100%, obviously. Um, and then how and then after the winner is decided, you are going to win the probability you put on the winner. For example, this is the actual result. Packers won, Chiefs won, so you win 70%, you win 90%. And Bills won, you win 50%. And here, Bucks upset, so you only get 40%. And in total, you multiply them. Because they are probabilities, it is natural to multiply all of those probabilities. This is how much you win. Say 70, simply 70 times 50 times 90 times $40 is your price. For example, of course, it's imaginary game. So this is what we are going to play. Then you know this rule, and then you have to choose the probability very carefully. And like for example, this is a very stupid betting. Like if you put 0% on a team, and in the case if the team wins, your final award is zero. Your prize will be zero because of multiplying zero. So for example, so if you know this rule, you are not going to play this way. So this is just an it you know what I'm saying. So I believe you understood the setup. So this is the game we are playing. So now now you have to assign the probability very carefully, which is exactly probability estimation. This is how we estimate the probability. So in our example, it is not the probability of win, but the probability of a mortgage application is denied. That is what we are going to estimate. So the maximum likelihood estimation method plays exactly the same game. So you will see why I said this. So let's come back to mortgage application example. Suppose that there are 7 applicants observed, A, B, C, D, E, F, G, and we observe you have to bet. Now you are playing the same same game. You bet on so you have to bet for each individual on how much he or she is going to be denied or approved. So you put probability on denial and approval. But you may utilize the information about payment income ratio, PI ratio, is available to you so that you can determine the probability more carefully. So, for example, the first applicant had only a 0.25 ratio, so you bet 80% on denial, and B has 30% PI ratio, so betting is 70%. It's not a good betting. Anyhow, in this way, you have to carefully choose, balance the denial and approval. You don't know, so it is a game, and then once the results realize then you collect this probability, this probability, this. So you win the multiplication of all the probabilities you assigned to the realizations. The realized, right? So then again, coming backwards, you have to estimate this probability very carefully. Excuse me, I changed it, so denial. You had to say denial, approval. Anyhow, it doesn't, it's my typo, my mistake. Uh, so anyhow, in here, your probability must be chosen very carefully. That is the basic problem we are facing. And here, we are going to add another rule. So we are not just predicting the probability without any model. We use the model. We have to impose the model on this game. That is, you are not choosing the probability, but you only choose beta 1 and beta 0 and beta 1. So this is the only choices you have. You have choice over beta 0 and beta 1. So once you specify these two parameters, the probability will be calculated automatically by this formula, which is the probit model formula. If you use the logit model, the formula will be different, but idea is the same. Anyhow, so given the PI ratio and given your choice of parameters, calculate the z-value first, and then calculate the probability of denial and approval. So this is what we are doing. This is the game we are playing now. And say, so this is the final betting. I bet this way. Of course, beta 0 and beta 1 should be chosen more carefully. And another difference here, so if you understand what's going on, actually, the structure is the same, but another key difference in estimation is that you observe the result ahead. You observe the results and then choose beta 0 and beta 1. That is the major difference in here. So you already know that you observe from the data that this applicant is approved or not. So based on that, you can just maximize your price. That is the maximum likelihood. And of course, another difference is that even if you choose the optimal parameters, you don't win anything. You don't win any money here. That's the another difference. And so, in summary, the maximum likelihood estimation can be understood as you are betting on n numbers of matchups or applications, mortgage applications. They are same. They have the same structure. And for the ith matchup, like ith individual or ith matchup, y equals to 1 if the team wins or denied, or the application is denied, and 0 if the team loses or the loan application is approved. And xi is the information you can utilize, like PI ratio or say the football games played that season, so you know how strong the team is. And as I explained before, you are not choosing the probability but the parameters. So you cannot choose the probability in any you cannot choose them directly. And then suppose that once you choose the parameter beta may include beta 0, beta 1, and more parameters, and then the probability will be calculated automatically by a certain formula. Say, I will just write it as f. The function f depends on the information and your choice of parameters. you may think it as this function. This function, it is a function of x and beta parameters. So you may use the probing model, you may use the logic model, and there are other models you can use. So they may be applicable to here. And then if one realizes, then you win this much probability. This is the correct probability. And if you fail to predict the realization, then you win 1 minus the other probability. So, and finally, multiply all the probabilities you win. So then multiply them, and that is your final score, final grade. And you are going to maximize that. And we call this score, the grade, as the likelihood, because it means likelihood means it is the probability of the observations, the realizations. So the realization is as likely as this in your estimation. So in that sense, it is called likelihood. And the likelihood can be simply written mathematically in this way. You do not need to read it carefully, but the idea is we have to handle two different cases, 1 or 0, whether the outcome is 1 or 0. But it is very cumbersome to think about two cases all the time. So in one line, you may write it this way. This formula implies this probability when y equals to 1, and 1 minus the probability if y equals to 0. Exactly. So one single formula can handle two cases at the same time, and you multiply all of them. This is like sigma product multiplication for I from 1 to n. Multiply all the things, and this is the likelihood function. You win this much probability from the betting. And mathematically, it can be further simplified by taking the logarithm. So we usually, in practice, we use log likelihood function. But it is just simple algebra, which is not important at the moment, I think. And because you already observed the realizations, so choose the parameter that maximize the likelihood function. That's it. That's how we estimate the parameters. And I try to explain the idea of MLE. MLE is called usually MLE. MLE in an easy example. I just wanted to give you the intuition, the motivation why we are estimating it that way. Okay, in the next video, I will do a little more formal approach to the MLE estimation. So see you later.